Hi there YouTube. So slightly different video to normal this time. It's just going to be a long time lapse of assembling our latest bit of kit. It's a Prusa XL 3D printer. So previously we had a Prusa i3, had it for more than 5 years now. It's been quite a good workhorse in that time. I mean, it's clocked up many days or probably weeks, well yeah, definitely weeks worth of continuous running. Certainly it's printing face shields during the pandemic and all the parts we need as well. So yeah, it's done good service. And it was a pretty good bit of kit, but the XL's promised to be better in every respect, really. As well as bigger, it's also faster, more accurate, and probably one of the best things is it's got two separate print heads, so you can do proper multi-material. I did try the multi-material unit for the i3, but that wasn't terribly successful actually. It's really intended for doing just different colours of the same material. If you're trying to do things that have different temperatures, and trying to do flexible and solid sections, you can't really do it with the multi-material add-on for the i3. But the XL's got two completely separate print heads, so you can load up one with one material, load up the other one with the other material, and then you can print things like soluble supports and yeah, flexible sections in solid materials. So yeah, just watching the assembly going. It went reasonably well actually. It was quite a satisfying kit to put together. No massive problems with it. A few bits I didn't quite understand the first time and had to reread the relevant sections in the online manual and try again. But yeah, it all went together really nicely in the end, and I've now done my first few prints on it, done the test items that came preloaded into it, and started making a few little bits as well. And yeah, so far so good. It seems to be performing really well, and yeah, big step up on the i3. The kind of things we 3D print at Avian kind of fall into three categories. So first off, there's the prototyping, which is really handy just in itself, just being able to try stuff out quickly. So things like the carrier wing folding, when we were developing that, we went for a load of iterations of different tip caps, just trying to get the geometry just right. And although those items weren't it's heavily loaded bit on the glider, so you'd never want to 3D print those in for real, but just for being able to mock something up, and it was strong enough to be able to rig the glider at least with and have it sat on the floor and just check we got the geometry right and keep modifying it until we did. The other thing that we're doing quite a bit with the 3D printer is printing moulds, so making carbon fibre bits, and you can print the tools for smaller carbon fibre items, and now obviously with the XL we'll be able to print moulds for slightly bigger carbon fibre items, which will be really good. And then the final thing is there are a few little bits that we do on the 3D printer now for the actual gliders, so obviously the unloaded bits, so things where little bits of guide for guiding VG cords around the right side of things. Those are quite handy to do with the 3D printer. Instrument mounts is another thing. I fly with my own 3D printed instrument mount, and I found that works really well. Obviously you can make it for whatever size base bar or whatever we have. Got a couple of examples here of bits I've made while I've been trying it out. So first here there's little guides for VG pulleys, so done a dozen of those. Those are made out of polycarbonate, which is printed okay for small items like this, but I think if we're doing bigger things out of polycarbonate, it's going to need an enclosure around it to keep the heat in. That's what I did on my previous one. And then another example here, this is something we're doing for a new prototype, but it's basically trying to make something which is, you can see, is soft in places, very easy to squish that around the edges. The yellow bit's soft, but the black bit in the middle is hard. So yeah, another example. You couldn't really have done that previously with the old printer, so that's something that's completely new with this one. Yeah, we're starting to find more and more uses for the 3D printer now. and yeah, hopefully with this new one we'll find even more. So yeah, if you want to watch the rest of the time lapse, see how it all goes together. This was while I was back home at my parents'. I thought I'd have a nice time to have a bit of peace and quiet and get on with it. The video's accelerated at 30 times, so it takes about 12 minutes to do at this speed. So that's about 6 hours of total assembly time. I've not really cut the video, I've only cut out the bits where I'm not in the room and nothing's happening. So what you're seeing is basically the whole warts and all assembly process all the way through.